So in part G, we are told that W represents the distance between the turtle and point D at time t seconds. We need to use our expressions from the previous parts to write an expression for W in terms of t. So what we can consider is that we have this d of t function and we have the g of t function, and the distance from the turtle to D will simply be the difference of these two values of these two distances. So we can say W of t is simply 0.05 t squared plus 1.1 t plus 18 minus 20 sine pi over 8 t, and it's all divided by sine 2.37 minus pi over 8 t, and this all has to be an absolute value as we simply want the distance, and this can be negative as well, but we don't really care about those situations. We just want the distance in absolute value. And then in part 2 we need to see where and when the water meets the turtle. So that's when this function will be equal to 0. So when their distances will be the same, so their differences will be 0. So we can do that by opening a new graph, and then if we can enter this function, so an absolute value, let's enter this function, and we want to see where this will be 0. So 1.1x plus 18, and then minus a big fraction 20 sine pi over 8 pi over 8x, and this is all divided by the sine of 2.37 minus pi over 8 again times x. And now I see that I've put the x in the wrong place. It has to be inside of the brackets like this, and hopefully this should look like this. We can analyze graph 0. So we see that this function has a 0 at t is equal to 3.35. So this is the time when they meet, and we also want to see where. So to do that, we simply need to go back to the function for the turtle. So what we need to do is plug this time into the turtle, and so this will be 22.2 approximately if we plug in this time of 3.35 into this expression.